If you're anything like me, you might have bought one of these cheap STM32 microcontrollers off of eBay, and unfortunately when you first plug them in via the USB, you're going to get probably unrecognized device, and the reason being is that these usually don't ship with any kind of bootloader loaded onto the microcontroller. So before we can use them conveniently, we need to get a bootloader on here, and unfortunately most of the options require some sort of extra hardware, because we've got a ST-Link port on the side which requires a USB to ST-Link adapter, and our other option is we've got 3.3 volt serial port on the GPIO pins here. The serial port can be used from the PC with a USB to 3.3 volt serial adapter cable, but I didn't have any of those, so what I thought I'd give a shot at doing is using the 3.3 volt serial on the Raspberry Pi to program the STM32. So what we're going to do today is have a look at achieving that. Before we can burn our bootloader, we need to make a few tweaks to our Raspberry Pi's environment. So we want to go ahead and log into our Raspberry Pi, and the first thing we want to do is we need to compile our STM32 Flash utility from source code. The reason we need to do this is it's not in the Raspberry Pi repo by default, so this is fairly straightforward, and we just need to clone a Git repository. If you want a list of all the commands that I execute during this video, look in the description of this video and click the link to go to my blog, and they'll all be listed there, which will be a lot more convenient than copying them out of the YouTube video. Installation of this is pretty easy. It's basically a git clone and then a make install, and I haven't had any trouble with it so far. So just after those two Flash steps, we should have our STM32 binary, and it looks like we do. The Raspberry Pi 3 has two serial ports, a hardware one and a software emulated one. By default, the hardware emulated one is used by the Bluetooth module, and the software one is exposed to the GPIO pins. Burning the ARM microprocessor requires the use of even parity bits, which is only supported by the hardware serial port. So that means for us to get our burning working, we need to swap which serial port is used on the GPIO pin and which is used by the Bluetooth. So if we look what serial devices we have at the moment, it'll only list this one, which is used by the Bluetooth. And what we want to end up with is a situation where we've got both ports exposed and which port TTYAMA0 has been swapped to serial 1. So the way we do this is we edit boot.config, and right down the bottom we add a single line, which is this one here. And again, for a list of all these commands, check out my blog in the description of this video. So that's step 2 of what we need to do to set up the environment. The very last thing that we need to do is, by default, a console is turned on serial port 0. And if we're trying to burn the ARM microcontroller, then this console is going to get in the way of what characters we want to send. So we need to edit command line.txt and delete the line that talks about the console on the serial port. Save that. Once that's done, we can reboot our Pi, and what we want to do is check that our serial devices have changed as we expected it. So we'll just give that a few moments. So what we're expecting after the reboot is our serial devices to look along these lines here. and we can see that's successful. The last thing that we need to do is wire the Raspberry Pi to the microcontroller for a serial interface. One quick thing we need to do first is move this little jumper from here to there so the micro boots system memory instead of flash. The system memory contains a serial bootloader we want to use. So we've just shifted that jumper over one. The next thing we're going to do is plug everything into the Pi, and what we're going to do is use this red wire for 3.3 volts, this black wire for ground, yellow for the transmit pin on the Raspberry Pi serial, and the purple for the receive. So the red pin is right there in the corner, which is the easiest one. And then with the black, we want to count 1, 2, 3, and it goes on the third pin, which is ground. Immediately adjacent to the third pin is our transmit pin. Get that on there nice. And then finally our receive pin. So ground and 3.3 volts on the ARM microcontroller is nice and easy because they're both exposed onto this header on the side here. So ground there, 3.3 volt there. Now transmit and receive on the ARM are actually pins analog 9 and analog 10 on the GPIO, but because we want to have the transmit from the Pi go to the receive on the microcontroller and the transmit on the microcontroller go to the receive on the Pi, what I suggest we do is we start backwards. So we'll put the purple one on first and we'll connect that to analog 9, and then the yellow to analog 10, which is our transmit on the Pi, but the receive on the microcontroller. Once that's all wired up, we can power up the Raspberry Pi via the USB interface. And if you haven't got anything horribly wrong, you should see the little yellow power LED light up. Alright, now on to the next and final step, which is to burn the bootloader for the microcontroller. Now that the STM32 board is wired up to our Raspberry Pi, we want to log back into the Pi, and we're going to check if the serial connection is working. Before doing anything, press the reset button on your microcontroller, otherwise the serial link might not be functional. To check the serial link is working, we can run STM32 flash and pass it in our serial port that we prepared earlier. If everything's worked fine, you should see a message similar to this one where it prints some information about your microcontroller. If it doesn't, check your wiring, press the reset button and give this another shot. Once you do have this working, we want to select a bootloader to write, and what I'm going to use is the bootloader provided by the STM32 Arduino project. You can find links to the bootloader on my blog. Check the description on this video. So we'll download the bootloader using wget, and then the next step is to run stm flash, and here we're passing in the command lines -v for verify, -w for write. Press enter. Wait for a few moments, and you should see a successful message along these kind of lines. And now you're all done. You should be able to set the jumpers back to their original positions, unplug the microcontroller from your Pi and plug it into the USB port of your PC, and you'll now be able to use the STM32 Arduino software to compile and upload your sketches.